In lesson 11, we're going to continue our practice with prisms by calculating volume of prisms and cylinders. So let's take a look at activity 11.1 on page 281. Determine the height of each solid. Okay, so just figure out the height of each solid. So height being here, okay, and then here would be the height in this one. So figure those out. If you need a hint, Pythagorean theorem will be useful, and so will trig. So for this first one, this 17.3 is actually over here as well, so it's that slant. So that's your hypotenuse of a right triangle. So we can do 17.3 squared is equal to our height squared plus 6.5 squared. So then calculate 17.3 squared is 299.29 is equal to h squared plus 6.5 squared, which is 42.25. Then you can subtract 42.25 from both sides to get h by itself. And you'll have 257.04 equals your h squared. How do we undo a squared? So you square root to undo a squared. So square root of 257.04 is 16.03. So your height to the nearest tenth would be 16, because this would be a 0, so 16.0. So 16 inches for the height in that first one. For this second one, so the 12 will also be this slanted segment here. But so for this one, we don't have two of the sides like we did in the first one. So this one, we have this side, but we don't have either of these two other sides. We do know the height and the plane of the base make a right angle, and we're looking for this. So if we use trig, we've got this 50-degree angle. So this is the opposite side. The 12 is the hypotenuse. So we can put together a sine function. So we can do sine of 50 equals h over 12. So then do sine of 50 in your calculator, and you get 0.766 equals h over 12. Change that into a proportion and cross multiply. So we get 1 times h is just h, and then 0.766 times 12 gives us 9.19. So if we're doing to the nearest tenth, we would get our height here of 9.2 millimeters. All right, then in this next one, it's called The Choice is Yours. So I want you to circle two of these solids that you think will be the easiest to calculate their area, or sorry, their volume. And then I want you to box in or square two that you think will be the most difficult. So which two do you feel like are going to be the easiest for you to calculate the volume? And which two do you think are going to be the most difficult? And then in your book, write down why you made that choice. So why did you choose the two you chose as easiest, and why did you choose the two you chose as hardest? So now that you've chosen that, I want you to calculate the volume of 3 solids. Okay, so 3 solids. 1 needs to be from your easiest list, and 1 needs to be from your most difficult, and then you can choose another. So if you want to do just 1 from your easy, 1 from your difficult, and then another one, you can. You can do 2 from your easy, 1 from your most difficult, but just choose 3 solids on here to calculate the volume of. All right, then if you're working with somebody else, go and compare with them. What did they choose as the easiest? What did they choose as the hardest? Talk about why you chose that. And so maybe, maybe you chose C as one of your easiest ones because calculating the volume of a rectangular prism is just length times width times height, and you see all of those measurements. So you said to find the area of the base, it's just going to be 7 times 5, and then times the height. So 35 times 10, and you're getting 350 feet cubed, and that felt like it was going to be pretty easy. Okay, maybe you saw calculating, maybe E seemed pretty easy because you've got the radius of the circle. So to find the volume, or to find the area of the base, was just going to be pi times 20 squared. And then timesing by the height, which was given to you. So then multiply by 15. And so felt like that would be pretty easy because you would just need to type in 20 squared times 15 into your calculator and get 6,000 pi inches cubed. You could also multiply 6,000 times pi to calculate an estimate of 18,849.6 inches cubed. Maybe you felt like A was going to be kind of easy because you have a triangle base, but you had the base and the height of it. Okay, so figuring out the area of the triangle, you were just going to do 5 times 11 divided by 2, okay, for the area of that base. So 55 divided by 2, and you're getting 27.5 for the base area. So then your volume, you're just going to need to multiply by the height. So you had volume equals 27.5 times 8, and felt like that was pretty simple to calculate. And then maybe you chose these other ones were going to be a little bit more difficult because this one, B, didn't give you the height. So you knew you were going to have to find the height similar to what we did in the warm-up. So you were going to have to set up a trig function. So we knew this was 10. We're looking for the height. So we're going to have to set up a sine function. So sine of 40 equals h over 10 in order to get that height. Then multiply that by the base. So sine of 40 is 0.64. 27 equals h over 10. So multiply that 10 up, and you get 6.4 as your height. Then you still need to calculate the area of the base times that. And in D, you have the kind of height of the base. So you still need this number because you need base times height divided by 2. So you would have had to have done Pythagorean theorem, 8 being the hypotenuse equals 7 squared plus x squared. Calculated that to get the area of the base times the height, and so on for these others. Okay, so you have this 4, you need this one. So there was a calculation you had to do. And maybe in G, you said, I don't even know what C means. Okay, C is the circumference. So this is 2 times pi times the radius equals that 4. So you're having to go back in and calculate what the radius would be before you can get the area. So we can do pi times the radius squared. We need to know that radius first. So hopefully noticing things that made calculations a little bit easier and noticing when something was missing. All right, then let's look at an application of this stuff. So this is the Cayenne Tower in Dubai. So here's where Dubai is in the world. Okay. It's this tower right here. Okay, this kind of rotating one. So it's 306 meters tall, which is 1,004 feet. Each floor is shaped like a chevron, which you'll see on the next page. And it's rotated 1.2 degrees from the floor below it to make that spinning thing there. And then there's a cylindrical elevator in the center. That's like a service elevator, and it's actually a residential apartment building. So it's an elevator that people can get to their floors in their apartment buildings. So here's a cross section of what that area looks, or what the floor looks like. Okay, so we've got this kind of shape here, and then this circular cylindrical elevator in the middle. So there's the dimensions. So the area of the base is just 57 times 35. Okay, so 57, so 35, and then times 57. So why is it possible to just multiply those two directly instead of having, so if we look at this, we've got these two kind of parallelograms here put together, and they kind of turn, right? Like it turns in. Why can we just do 35 times 57 to get that area? So if you think about this, the height here would be half of 57, and the height here would be half of 57. So if we do 35 times half of 57, and then we do 35 times half of 57, and we add them together, okay, we're just going to end up with the same answer as 35 times 57 directly. So that gives us 1,995 square meters for each floor. So how could we figure out the total volume? So this is giving us that this cross section is 1,995 square meters for each section. So how could we figure out the entire volume? So remember, volume is area of the base times the height. So we have the area of the base, so we would just need to multiply by the height of the building. And we're in meters. So remember, I told you that the height of this building in meters is 306. So you could just multiply those. So 1,995 times 306 gives us a volume of 610,470 cubic meters. And then we talked about the shape of the core here. So this is cylindrical. It's just going to go down this center. And so we said it's cylindrical, or a cylinder shape. So how would the volume of the building's core be calculated? So again, it would just be area of its base shape times the height. The base shape here being a circle with a, no, did they say it was a diameter? Diameter 17. So how do we find the area of a circle? So area of a circle is pi times your radius squared. So if the diameter here equals 17, divide by 2 and you get the radius. So the radius is 8.5. And then the height of the building is still 306 meters. So the height of the cylinder is going to be the same as the height of the building, and then you can just calculate this. So 8.5 times 8.5 times 306 times pi. So once we calculate this all out, the volume of the cylinder is 69,455.9 meters cubed. So this is the volume of that cylinder. Here's the volume of the whole building. So here's the elevator in the middle. Here's the whole building. So if we're doing percentage, percentage is always part divided by whole. So our part of the volume, so the volume of that cylindrical elevator is 69,455.9 divided by our whole volume, which is 610,470. So calculate that, you just divide. So type in 69,455 divided by 610,470. And we would get 0.1137. Remember, percent, you just multiply by 100. So we get 11.4%. 80% of the total volume is taken up by that elevator. So how are these floors in this building similar to cross sections? Okay, I would say because they're two-dimensional shapes. So you get those two-dimensional shapes, okay, that are all identical, same as the base. But how are they different? These are rotated. Okay, so these are rotated around versus just slanted. So an oblique would just be slanted. So if we we're drawing an oblique versus it just being straight up like this. Okay, for an oblique, it would just be, those sides would be slanted instead of rotated. So they'd be, you know, kind of this way to create the oblique shape. So rotated versus just slanted. So even the floors aren't exact cross sections, we can use reasoning involved with cross sections compared to volume of the original building in our imaginary rotated building. So how do the volumes compare and why? So if we thought about this, you know, if these were our note cards that were shaped like this from the last lesson and we stacked them on top of each other, if we just rotated them, would that change the area or the volume? And so it would stand to reason that that rotating it isn't going to change the size of each card. So in this case, again, all the floors are identical in area and we have that height. So the volumes should be the same. So then finding the volume of the tower like we did on the last one, area of the base times the height. All right, so what measurements are needed to calculate the volumes? So for a rectangular prism, remember that the base shape equals a rectangle. Okay, so you need the length times the width. And then you also need the height of the shape. Okay, so the height between those bases. Prisms with triangular bases. Okay, so if there's a triangular base, you need the base and the height of the triangle. Whoops. So base and height of the triangle, or the legs of the triangle. And then you also need the height of the prism. And cylinders. Okay, so a cylinder has a base shape that's a circle. So you're going to need the radius. Since area of a circle is pi r squared. So you need that radius measure. And then just like the others, we need the actual height of that cylinder. And then when do we need to use Pythagorean theorem? So Pythagorean theorem would need to be used if you know two of the sides of the base triangle, okay, but you're missing one of them. And it only matters if you're missing one of the two legs. Okay, so if you have the hypotenuse, okay, and you have one of the legs, then you're going to need to use Pythagorean theorem to find the other. So we can do area. Because if you already had this, so if you knew this and you knew this, you can find the area already. Because it's just base times height divided by 2. So we would not need to do Pythagorean theorem in that case. We would in this one. And then when do you need to do trig? When you only know one of the sides and you know the angle. So if you know this angle here is given to you, so if you knew this was like 31 degrees and you knew one of these sides, okay, so you knew this, then you could find the other leg. So you only have one side. All right, lesson summary. So sometimes we need additional calculations to help us with volume because we don't have enough given to us immediately. You'll see in the cylinder in your book, they give you this diagonal across the cylinder. So that helps us find the height because it's the hypotenuse. And then we've got the height. We've got the radius, okay, which is part of the leg. So they give us this radius here. But we know this hypotenuse goes across the whole base. So then we know that the whole thing would be 10, since this radius is 5, 2 of those would be 10. We could do Pythagorean theorem to calculate this height, which is what they did here. Then you'd be able to calculate the volume because you've got the radius for the base. So you'd be able to do pi r squared, okay, which they did for area of the base. And then once you've calculated the height, you could multiply by the height. So sometimes if you're missing a measurement, you're going to have to go back in your vault of things that you've learned to come up with the calculations necessary to get area of the base times the height.